The HFW59D RF meter kit is a professional-level, far-field broadband RF meter designed to measure microwave radiation from 2.4 GHz to 10 GHz. The values displayed are the sum of all the sources within the frequency range of the meter. This frequency range covers the radiation emitted by Bluetooth devices, WiMAX, both the upper and lower Wi-Fi bands, and radar signals. The meter displays the RF power density measurement in microwatts per square meter or milliwatts per square meter in its highest range. Included with the K5 carrying case is the HFW59D RF meter with a rechargeable battery, a silicone protective cover, an AC battery charger, a UBB2410 ultra-broadband omnidirectional antenna, a log periodic directional antenna, an HV20-2400G10 preamplifier, the operating manuals, warranty, and certificate of factory calibration. The meter's adjustable audio tone replicates the signal patterns and intensity of measured RF emissions, which aids in source identification and direction. Headphones can also be used with the HFW59D instead of the built-in speaker by plugging them into the headphone jack as shown. Note that this jack is hidden by the silicone protective cover. Also included is an auto power off function after 40 minutes to conserve battery life. The auto power off functionality can be disabled by the connection of an AC adapter or a data logging cable to the DC output jack described later in this video. A full charge will power the meter for about 3 hours of continuous use with the UBB2410 antenna attached, and approximately 7 to 8 hours with the log periodic antenna. When the low battery message appears in the display, recharge the meter by plugging in the AC adapter to the power jack as shown. This green light will show that the meter is charging. A full charge will take about 10 to 12 hours, and the green light will go out when the charge is complete. The HFW59D itself offers excellent sensitivity down to 1 microwatt per square meter and up to 19.99 milliwatts per square meter or 19,999 microwatts per square meter in 2 ranges. By using the included HV20 preamplifier, the minimum range is extended down to 0.01 microwatts per square meter. The meter includes an AC and DC output jack to supply signals to more advanced testing equipment such as an oscilloscope, spectrum analyzer, or data logging equipment. The AC output jack can also provide the detected audio portion of the amplitude modulated or detected pulse digital signal, and the DC output provides the interface for long-term recording of the measured value. Its full-scale output can be set to 1 volt DC or 2 volts DC and can be used to send data to any of the NFA series meters. You can also use an external logging device of your choice. It is recommended to use the 1 volt DC output setting as the default. The HFW59D has the ability to measure in 3 signal modes: RMS, a time average signal value, the peak value, and peak hold that shows the highest output of the signal over time. This peak held value can easily be cleared by holding the clear button directly above the display. Always use the peak or peak hold signal measurement mode when comparing your results to building biology guidelines. The HFW59D has patented circuitry that allows the accurate measurement of the extra-fast rise times and needle-like peaks that are present in modern RF modulation techniques. To further facilitate this, the HFW59D also has the ability to change its measurement bandwidth in 2 ranges. VBW standard is used by default. VBW max is only used when measuring radar signals. The meter can detect events down to 33 microseconds in VBW standard mode and down to a 0.5 microsecond event in VBW max mode. Since this is much too fast to show, the numerical display itself updates every half second. In peak mode, the display actually shows the average of peaks detected within this half-second interval. Note that this display averaging has no effect on the actual measured values sent to the AC or DC output ports. To display the highest peak received, use the peak hold mode. When measuring high crest factor signals in VBW standard mode, such as WiMAX, Wi-Fi, and 4G during data transmission, determine what percentage is a high-speed service and apply the following correction factors. Multiply by 2 for a slightly audible high-speed service, multiply by 5 for a 50% ratio, and multiply by 10 if the service is predominantly high speed. To attach either antenna, connect it to the antenna socket as shown. The connection should be snug, but be careful not to over-tighten. When the UBB2410 antenna is properly attached, you will see a green light as shown. When the log periodic antenna is properly connected, you will see a green light here on the antenna itself. The log periodic directional antenna measures in the direction that you are aiming. If you could see its detection pattern, it would look like this. With this directional pickup pattern, this antenna's best use is to identify the direction of a radiation source. After the source or sources are known, further measurements are done with the omnidirectional UBB2410 antenna, which measures radiation from all directions simultaneously. If you could see its detection pattern, it would look like this. If you do not know the source direction of radiation, begin measuring by attaching the HV20 preamplifier between the meter and log periodic antenna as follows. With the meter off, attach the HV20 preamplifier to the meter. Connect the antenna to the preamplifier as shown. And finally, change the external adapter switch to the plus 20 dB position as shown. When the HV20 and antenna are properly connected, they both will show a green light. Be sure to return the external adapter switch to the 0 dB position when removing the HV20 preamplifier. The HV20 preamplifier can also be helpful to boost very weak audio signals from the meter to help identify and trace the source of weak radiation sources. To begin measuring, set the signal range to minimum and set the signal mode to peak. Slowly scan an area and follow the direction of the highest field strength or loudest sound. Rotate the meter 90 degrees and back and around the area to find the highest values. If the meter shows only a 1 at any point, then switch the range to maximum and continue scanning. Once you know the source and direction of concern, continue measuring in the affected areas with the UBB2410 ultra-broadband antenna. Before changing antennas, power the unit off. The purpose of the UBB2410 antenna is to measure total RF exposure from all directions at once. This simulates what your body experiences with exposure from all sides across a large frequency range. The other advantage of measuring with the UBB2410 antenna is that it's better equipped to detect hotspots caused by complex reflections. These small, localized areas of high radiation are common inside buildings. To measure with the UBB2410, be sure the green light is illuminated on the antenna and remember to start with the lowest range possible. While measuring, try to keep the antenna as far away as possible from you to reduce the field distortions from your own body. This means that if you're standing with the meter in front of you, your body could be blocking some of the radiation that's coming from behind you. Slowly scan an area by rotating the meter 90 degrees and back, and slowly move it around the area for at least 15 seconds to find the highest reading possible. Adjust the volume level of the sound as needed. The best technique to measure total exposure is to use a figure-8 pattern like this in peak hold mode to show only the highest peak levels. This method effectively captures hot spots and radiation in both horizontal and vertical polarizations. This mode is also useful for measuring intermittent sources of radiation, such as radar. The peak hold also allows you to look elsewhere without missing the highest level that the meter recorded. Note that after displaying this highest measured value, the meter reading will slowly decrease until a higher peak is measured. This peak hold, droop, or decay time can be changed with this switch as shown. The plus setting is standard, and the minus is a faster decay time. If you need to clear this peak held value, simply press and hold the clear button as shown. If the display is showing only a 1 at any point, then increase the range to maximum and continue scanning. If you need to measure higher power levels above 19.99 milliwatts per square meter, the optional DG20 G10 attenuator may be inserted between the antenna and the meter. Use the same technique as installing the HV20 preamplifier earlier in this video, but the external adapter switch would now be in the -20 dB position. And again, if you are measuring in areas of little radiation that's less than a few microwatts per square meter, then attach the HV20 preamplifier. Once you have determined this highest reading, including the correction factors if applicable, compare it to the latest building biology guidelines. Always use the peak or peak hold measurement mode when comparing your results to the building biology guidelines. Currently, SBM 2008 is the most recent building biology standard. A reasonable goal after mitigation would be to have levels reduced to the slight concern level in microwatts per square meter as shown. For more detailed information about the HFW59D RF meter kit and examples of common sound sources of microwave radiation, please visit the Safe Living Technologies website at slt.co.